All right, folks, this is our last little piece of our discussion on the notes of maps, and we are going to kind of fill in the rest of our words here in just a second, but we also are going to need to have this other sheet from the same packet handy, so just keep that around. For right now, we're really just doing gradient, and I'm sorry this is on paper again. It's just the best way to do this, considering, instead of some other form of technology. I haven't figured that out yet, but for now, we're just going to go with this. Gradient is the change in elevation over a distance. So basically, it's how much do you go up or down in feet above sea level over a distance as you just sort of walk along in a certain direction. What is your change in elevation over that distance? Well, anybody who told you there was no math in this class lied to you. It's actually got an equation if you look here. Little g stands for gradient. This little delta symbol is a triangle. It stands for change in. You probably remember that from math. E is just elevation, and then distance is d. So super simple equation, and we're going to show you how to use it. You need to actually pull these kinds of numbers off the map in just a second. Another way of thinking of gradient is steepness. So basically, if you're walking around hiking or just wherever and you think of gradient, that is just how steep is the land that you're on. So the higher the steepness, the higher the gradient. And you may have actually seen road signs that look like that in the past if you're driving on highways. That is an indicator of gradient for truck drivers, because if the gradient gets too steep, those truck drivers want to make sure that they're traveling an appropriate speed and give themselves enough stopping distance. So you'll see signs like that. That's directly due to gradient or steepness of, in that case, the roadway. All right, so here's what we're going to do. We're going to get some materials together. You're going to want your pencil. And I have a calculator here because, you know, I love calculators. It's my favorite one, my lucky calculator. And you can use your telephone calculator or whatever if you want, no big deal. So here's what we're going to do. We're going to refer back to the map, and we're going to actually use official numbers right off this map, and we're going to figure out what the gradients are, and it gives you 4 different spots to look, or 4 different situations to look at, and we're going to go ahead and do that. But really quick, first thing is first, we're going to change this B right here. It doesn't make any sense to do a gradient from A to B, so it's going to be A to F. So go ahead and change that right out of the gate here before we even start. And what we're going to do is look at the map. And this map has all those little lettered locations on it, A, B, C, D, E, F. And we're going to refer back to a couple of those right now. So first of all, it's A to F. So A is up here in the upper left, and it means the dot for 110. So A is that 110-foot elevation, and then F is down here, it's at 27. So what we need to do to figure out gradient, and you can feel free to write the equation again if you want, it's delta E over distance. And we're going to just put some numbers in here. The elevation change part is easy. So you just take the number that you know is there, which is 110, and the other one's 27, and you change in means you subtract. So you just do 110 feet minus 27 feet. Super easy. Now the distance is how far apart they are. That's where the scale comes in, and you're going to need to get good at using that. And once more, I'm going to bring back a trusty straight edge piece of paper here. We're going to reuse and recycle because, you know, we're going green here. And I'm just going to mark off. Actually, the easiest way to do this is to just put your paper between A and F so that the line lines right up with A and right up with F. And you just make 2 ticks right where you see A and F. And then you bring it down to your scale. And so you see my little check marks here. You just bring it up to the scale, start at 0, and you go 1, 2. This was, I think, A. 1, 2, 1, 2. And then it's about 3. 3 is right here. So it's a little more than 3 miles. This is the hard part because you have to estimate. And I use 3.25 miles because if you look at where that falls, each one of these shaded, the dark shade, the white, the dark, and the white, those are half a mile a piece. So this little slice right here is about half of one of those blocks. So that's 0.25. So total distance is, what did I say, 3.25 miles. So here's what you would do. put that 3.25 miles right there. And then all you do is you get out your calculator and you subtract. 110 minus 27 equals divided by 3.25, and you get about 25 and a half. So, and you can round, this says 25.53, so just go to the nearest tenth, that's fine. So gradient equals 25.5, and you've probably heard science teachers in your past say that you cannot leave numbers without units. We call those naked numbers because that's kind of risky. You don't want to let numbers run around naked. They need units. So look back in your work and notice that you have feet over mile. Well, they don't cancel or do anything funny. They just show up again. Feet per mile happens right there. So if you think about it, it's how many feet did you go up or down in however many miles you just chose to walk. So if you went from location A to location F, you would actually, in this case, drop 25 and a half feet each mile you walked if this was the real Earth. Now, here's the deal. Why did I put 110 first? Well, that just eliminates a negative number. If I did 27 to 110 minus that, you would get a negative. And really, honestly, it just doesn't matter. Here's what a negative would mean. And you can, take this and use it or forget about it. But if you walk from A to F, you're going down in elevation. So you do you would technically do your final elevation minus your initial elevation. So it would be, in that case, officially 27 minus 110. If you were walking from F up to A, you're going uphill. So you do final elevation, in that case is 110 minus 27. So you get a positive answer because you're going up a hill. Honestly, I don't really care about the negative. I just want you to understand what the concept is. If you're going from one location to the other, basically the gradient is how many feet do you go up or down each mile. And it doesn't matter, you'll get the same answer no matter which way you walk. But if you want to be all official with it, you would put the final elevation and subtract the initial elevation. So that's just formality for us though. So here's what's going to happen here. We are going to do more of these, and I'm going to do B and E kind of with you, and then you guys can go and do B to D and then F to C. And then the answers are going to magically appear on this video. So you can feel free to pause whenever you want. If you want to try B and E by yourself right now, go ahead and pause. If not, I'm going to go do it. So here's how it works. G equals delta E again over distance. And for this one, B is right here. It's that 123. E is 80. So again, I'm going to put the bigger number first so I don't have any negatives to worry about. So 123 feet minus 80 feet divided by, and the distance, this is where you grab, and I can use literally the same scale that I used before, and I can figure out the distance between them. It's probably easier not to, so I'll still use the same piece of paper, but I'll just ignore that part. We're going to go from E to B, so you line them up so that the dots show up at the very edge of your paper, and then you just make a little tick mark on there. There's B, there's E, if you care. Bring it down to your scale, and this is actually going to be, what did I get? About 1.7. So if you look, this is a little easier because you don't have to move your paper. You're just going to count. Here's 1 mile right there. There's E, 1 mile. And then there's 0.5 is right there. So that's 1.5. And then you get a little extra. So that I'd said that's about 0.2. So that's 1.7 miles. So I can go back and plug that in. 1.7 miles. And weirdly, this actually almost turns out to be the same as the last one if I remember. It's 123 minus 80 equals divided by 1.7. And you get 25.3 if you round feet per mile. So 25.3. What that means is it's slightly, compared to A to F, this one is a slightly less of an elevation change for each mile than that one was. These other two are going to be really different. So I'll let you go ahead and do those. You can pause, and I'm just going to go ahead and work this out, and these answers are suddenly going to appear, and then we'll be done. Okay, gradients are done. Hopefully your answers match up closely with these. Now here's the deal. What if you didn't get exactly what I got? Does that mean you're wrong? Well, probably not, because these elevations are set based on the dots on the map, but your distances and how you interpret and how you read the scale and how tight you make your little tick marks on the edge of your papers and things, I mean, that's all going to cause slight variations. So let's go with this one, for example. If you got 34.5 feet per mile, are you going to get marked wrong and penalized? No. So don't worry about that. If you got like 10 or 53 or something, then I'd have a problem with that, but it's almost impossible to do that as long as you're careful, because you can always go back and check your own work and your own answers. And same here, if you got, this is kind of cool, this turned out, if you use 1.75 miles here, it turns out perfectly to be 4 feet per mile, which is kind of cool. If you got like 13 there, that would be kind of something went wrong. But if you're like 3.8, then great. That's fine. That means you probably had a little shorter of a distance on the bottom there. So let's just quickly look at what these numbers mean. These two are almost the same, so we'll just call that about 25 feet per mile. 35 feet per mile means it's a bigger number, number one. That means your elevation changes 35.5 feet in 1 mile, where these were only 25. So you're actually looking at a steeper slope. And if you look back at your map, B to D, look how many contour lines you're packing in there. You're crossing all these lines, so you're going down a lot of elevation each mile. B to E, not quite as steep from here over here. And then the most interesting one, I guess, is F to C. Look how many contour lines you cross when you go from F to C. Barely one at the very end. So that's a very kind of flat walk. So if you're a lazy hiker, you would want to go that way, and you wouldn't change much in elevation as you walk. So the lower the number, the more flat, more gentle the slope is, and that's what gradient's all about. So hopefully that was nice and informative. Do you have to be so mathematically precise when we start looking at maybe test questions? You'll see not so much. You just need to understand the concept of what a bigger number means and be able to roughly figure it out. And if you're really good, you can use the equation and figure it out very specifically. So that's gradient for you, and that wraps up our notes. So that's the end of this one.